Good morning. This is Carlos Camargo with WestEd PMP. The lines are now open, and as you just heard, we have started a recording so that we will be able to record a playback of this webinar and make it available probably by Wednesday for folks who were not able to attend but wanted to actually listen in. The files and the presentation will be posted on the SBAC internal website by Wednesday at the latest. We have started our recording and will begin our webinar in about 4 minutes. Welcome to those of you. Good morning or good afternoon, wherever you happen to be.
Five, six to mute.
We should probably mute him.
Good morning. The lines are now open for the Smarter Balance Assessment Consortium's webinar on the mathematics content specifications. Today is August 29th, and we will begin our webinar at 11 a.m. Pacific. If you are joining us this morning or afternoon, wherever you happen to be, and you want to place your individual phone line on mute, of course you can do so with your system's mute button, but also with your keypad by pressing *6. That will help us minimize background noise so that we can all enjoy a crisp presentation by our presenters today.
Welcome. This is Christian Mitchell from the WestEd and the PMP, and welcome to the Mathematics Content Specifications webinar. We have a full session today, and I wanted to open things up with an opportunity for the Executive Committee co-chairs to provide an opening remarks or any welcomes that they'd like to offer. I know that Carissa is on the line, likely on mute. I'm not sure Judy's been able to join us yet. Carissa, any opening remarks?
Thanks for putting me on the spot, Christian. I really was listening. No, I just
no worries.
Welcome to the Mathematics Content Specifications webinar on behalf of Park and myself. And thank you for taking the time for this really important work.
Thank you, Carissa. And I think if we could put ourselves on mute, and I will start it off by going through the agenda briefly. Excuse me, we're going to go through the roll call first as we did last time, pardon me. And for that, I'll turn it over to Carlos to conduct roll call for the work groups and also for state representatives. And I believe he'll start with states, and then we'll move into work groups. Thank you. Go ahead, Carlos, please.
Good morning or good afternoon. I will begin in alphabetical order. State representatives. Alabama. California. Colorado. Connecticut.
Connecticut's here.
Thank you. Delaware. Hawaii.
Hawaii's here.
Thank you. Idaho.
Idaho is present. We have several people on the call.
Thank you. Iowa. State of Kansas.
Present.
Thank you. Kentucky.
Oh, no, remember, I don't know.
Maine. State of Chicago. Excuse me, State of Michigan. Missouri.
Missouri is here.
Thank you. Montana. Nevada. New Hampshire.
Here.
North Carolina.
North Carolina is here.
Thank you. North Dakota. Ohio.
Ohio is here.
Thank you. State of Oregon.
Oregon here.
Thank you. Pennsylvania. South Carolina.
South Carolina's here.
Thank you. South Dakota.
South Dakota's here.
Utah.
Utah's on the call.
Thank you. Vermont. Our thoughts and prayers are with Vermont. Washington State.
Washington is here.
Thank you. West Virginia.
West Virginia here.
Thank you. Wisconsin.
Wisconsin is here.
Thank you. Wyoming. And I will go through the folks who were not here in case anyone's joined us briefly. Alabama. California. Colorado. Delaware. Iowa.
Present.
Thank you. Kentucky. Maine. Michigan. Montana.
Michigan's here.
Thank you. State of Montana. Nevada. North Dakota.
North Dakota's here.
Pennsylvania. Thank you. Anyone from Pennsylvania? Vermont. And Wyoming. Thank you. I will move now to the co-chairs and work groups. Is there a representative from the Accessibility and Accommodations work group?
Yes, there is.
Yes.
Thank you. Thank you. Item development.
PMP liaison.
Yes.
Thank you. Performance tasks.
Yep, Shelby's here.
Thank you. Test administration.
Yes, Sean is here.
Thank you. Test design.
Test design is here.
Thank you. Formative processes.
Yes.
Thank you. Reporting.
Reporting's here.
Thank you. Technology approach.
Present.
Thank you. And transition to the Common Core.
Is here.
Thank you. And the recently renamed validation and psychometrics.
Here.
Thank you. Thank you. That concludes roll.
Great. Thank you, Carlos, and thanks for everyone for chiming in for a roll call. We have on the slide deck right now the agenda. It's a jam-packed agenda. I wanted to just roll through it really quickly to give kind of an overview before we actually get started with the agenda itself. As you can see, we have questions and answers interspersed, sprinkled really throughout, so that way we have an opportunity to address any questions during the presentations as we move forward. We start off with the Common Core standards themselves, talking specifically about the priorities, the mathematics priorities. Then in the agenda, we move into an overview of content specifications, really the act and process of moving from the Common Core state standard to content specifications, how we do that, and the reason for doing that. That segues nicely into being able to just dive right into the content specifications to speak specifically about the claims therein, so the 4 claims within the mathematics content specifications. We really follow this up with the assessment targets, and that'll be presented by Karen Hess to speak specifically about those targets for assessment within the Common Core state standards as articulated in the specifications. We end with time for a quick review of the process for providing feedback and discussion of any open topics that we weren't able to address throughout the presentation or throughout the questions and answers period. I'd now like to be able to turn it over to Joe, and I wanted to check to see if he's on the line. I know he was actually trying to secure a location to join the call, and so let me see if he's joined. If he hasn't, then I can take it from here. Okay. So if you could, yes, thank you. Let me introduce the presenters. First is Joe Wilhoff. He's of course the executive director of Smarter Balanced, and folks on the phone know him well. Jason Zimba will be presenting the section in the agenda regarding the mathematics priorities. He's of course the co-founder of the Student Achievement Partners, and certainly had an integral role in writing of the Common Core state standards for mathematics. Linda Darling-Hammond, of course you folks know Linda in her role, especially her role as the serving on the Technical Advisory Committee, also the Senior Research Advisor for Smarter Balanced, and of course her work as professor in education at Stanford University. She'll be providing really a context, and will be providing the detail about the purpose of the content specifications and how we move from the Common Core state standards onto a content specifications document. Alan Schoenfeld is, of course, a professor at University of California, Berkeley. He's been integrally involved in writing of these content specifications. So when we get to the section of discussing the claims themselves, and we get into the real meat of this document, Alan will take us through some very important aspects of the document itself. Karen Hess, some of you know from the work on the ELA content specification and her work at the National Center of Assessment. She'll be kind of finishing off our dive through the content specifications, specifically discussing the assessment targets. And with that, we can turn it over to Jason to start us off with the mathematics priorities. And Jason, we will move the slides for you if you just let us know when you want us to switch to the next slide.
That's great. Can you hear me okay?
I can hear you fine. Thank you, Jason.
Okay, great. The first slide I have is number 4 on my printout. Is it number 4? It says Design of the Mathematics Standards.
It's actually number 5 now, but we have it up there.
Okay, so that way, if I know the offset, I can ask you which slide to show. I apologize if it's going to be a little bit stilted, everyone. I'm actually on vacation, and like Joe, I was trying to secure a location to do the call. I chose the parking lot of McDonald's in the town of Calcium, New York, and because it has cell phone coverage. So I ask for your indulgence as we go through this, and I'll try to be fairly quick because I understand that there's a big agenda. So looking at the slide, Design of the Math Standards, to talk about the design of the math standards and preserving the focus and coherence of the standards and implementation really means backing up to talk about the process that led to the standards, because it was different from garden variety standards development process, obviously for a lot of reasons. Studying for our purposes here, the working group, as you know, was charged with building on the best of what states had done in standards to build a foundation for college and career readiness with internationally competitive levels of performance. And to get there, we were charged with basing our decisions as far as possible on evidence, international comparison, syntheses of education research, major national reports, recommendations. And the slide that you're looking at is really just a thumbnail of the bibliography from the standards, which shows a sample of the works consulted, and there are some large studies there, some empirical work, some quasi-empirical work, some documentary evidence, and it's worth looking at some of those things. There are some lesser known but important documents listed in that bibliography. And as an evidence base for such a complex question, of course, it's noisy, but there are some fairly loud signals that emanate from it, and I wanted to pick out a couple of those themes and relate them to Smarter Balance Challenge for Designing Assessments today. So let's look at, I think it's slide 6. It shows a scatter plot.
Got it. Thank you, Jason.
One of the themes or signals that emerges from the evidence base is that post-secondary instructors would like to see the K-12 system prepare graduates with a deeper mastery of a tighter core. And this scatter plot is, and I know some of these thumbnails will be small, I'll narrate them, so don't worry if you can't make out the fine print. But this scatter plot is not meant to prove that assertion, but it's meant to be an example of the kind of thing you see when you look. And in this scatter plot, each dot is a skill. This was a national survey of post-secondary instructors, and on the horizontal axis is how important on a scale of 1 to 5 high school teachers thought the skill was, and on the vertical is how important the post-secondary teachers thought the skill was. And so the 45-degree line would represent agreement between the two groups as to how important the skill was. And you can see that I think it's 96% of the skills fall below the 45-degree line. And the picture that emerges from this study as a whole is one in which the high school instructors sort of think everything is important, but the post-secondary instructors are being far more judicious. They spread the ratings much more widely, and they elevate many fewer things to the highest level of importance. Let's look at number 7. International comparisons. And again, this is a thumbnail of Bill Schmidt's famous A+ composite, high-performing countries in the TIMSS study. There is, no two countries do it the same way, of course, and there's a lot of variability. But in the intended curricula of these high-performing countries, one can see a sort of a cascade in the structure of the discipline, and the almost as it were design principles that emerge from looking at these curricula are focus and coherence. And I'll say a word about them if we just go to slide 8. Are we looking there? Focus
yes, we are. We're
okay,
on
great.
focus and coherence.
Great. And so it's out of the TIM study, of course, that the mantra of mile wide, inch deep comes, and this critique of standards and almost actually to a greater degree textbooks also comes out of domestic policy recommendations and research. Another document I would recommend people look at if they haven't is the Mathematics Learning in Early Childhood, Path Towards Excellence and Equity. There are a lot of, as I say, convergent signals about bringing greater focus and coherence to the math instruction. And focus, essentially, as it says, means spending more time on fewer things at each given grade level. It's consonant with what the college readiness research points to, and coherence means structuring the learning so math makes sense. Math ought to make sense. It's the one subject where the truth of an assertion can be found by consulting your own mind. It's not an empirical subject. And the triangle diagram of Schmidt's A+ composite curriculum is really a symbol of structuring the curriculum so that it grows by increments and each thing makes sense given what everyone knows. And obviously, focus and coherence have a relationship. One, you focus so that there's time to make sense of the mathematics. And this also is one way to think about the mathematical practices. Mathematical practices are a kind of how math is done so that it is being worked with deeply, worked through deeply, and thought about as students work toward proficiency. Let's look at 9. Preserving focus, coherence, and implementation. There's not much here, but obviously in curriculum, instruction, teacher education, professional development, and of course the topic at hand, assessment, it's important that these implementation steps preserve the focus and coherence designed into the standards themselves. Let's look quickly at number 10, some implementation challenges. Why is this not likely to just happen automatically if we don't really think it through carefully? Are we looking at number 10?
Yes, we'll keep up with you.
Great.
Yep.
Great. I mean, the first challenge is just in general, any shift is hard to accomplish. This is a very large sector with traditions in the way that it looks at math, and some of them are challenging. Some of the focus talk is challenging, and it's a cultural shift, so that's just difficult. Another challenge of implementation is that the Common Core standards are pretty finely balanced along a few dimensions. They stress conceptual understanding as well as procedural skill, as well as being able to apply what you know. These are, any given figure in math education probably loves one of these more than the others, and the standards really insist that they're all important. And that balance, to put it mildly, Alan has written about this, the math education world hasn't always been balanced, and the standards are trying to strike a good balance that works for kids. Connecting content to practices is something the standards demand, but it's really in math problems that happens, problems in the curriculum, problems in the classroom, problems on tests. And so that has to be talked about. That makes implementation less than automatic. Another challenge, which I'll dig into a little bit, is the issue of grain size in these standards. These standards are in some sense a slightly different genre than we're used to seeing, and often state standards, each item is supposed to be the same grain size, whatever that means, as another, and so you could kind of snip them up into confetti and draw standards out of a hat and feel like they're all the same size, and that's actually not the case in the Common Core standards. There are also, and I'm not a psychometric expert, but there are aspects of psychometric culture with its traditions of sampling and its content-free theory of measurement that can make this a communication challenge between subject matter experts and assessment experts. And Smarter Balance is committed to really working deeply across those varieties of expertise. And because of these challenges, we're going to see about a way to carry the focus and coherence of the standards forward by making implicit priorities more explicit. Let's look at number 11, which is about K-8. I'll talk first about K-8 and then about high school. So preserving focus and coherence by setting sound priorities in K-8. So good priorities can help you follow the contours of the progressions in the standards. These standards are not so much assembled out of topics as woven out of progressions, and priorities can trace the ebb and flow of the progressions, balance the journey and the end point. So you have some important beginnings, concepts of place value in the early grades and multiplication, division, say in third grade, and you have some important endpoints, being fluent with linear equations, and both the beginnings and the endings are important, and good priorities can make sure that sufficient attention is paid to both. There are shifts in focus from grade to grade, like I said, the ebbs and flows, and there is also the need to make sure that when we say focus, we're focusing on what matters most to making sure kids stay on track to college and career readiness. Look at an example in grade 3. This is going to be, what will it be, 12?
Yes.
Yeah, I'm sorry, my thumbnail has obscured the 8 number on my
we're keeping up with you.
Okay, great. So in grade 3, there's a kind of a, if you look in the specification document you have, sometimes people are surprised to think about number and operations in base 10 being a second priority in third grade, because of course we all know arithmetic is important in the early grades, multi-digit algorithms, and we may have heard, you read the Fordham report, everyone says the Common Core standards focus on arithmetic in early grades, and yet there is an important feature of the way the standards are designed that in grade 3 there are some very important beginnings. Multiplication and division, the concepts of multiplication and division, and their applications, and becoming fluent within the times tables, all within third grade, and making sure that those things are in our first priority is a way to take the guesswork and to make sure that these features are not missed. If you look at what's done in third grade in base 10, it's rather small and ought to be. It's actually bringing to fluency for those students who weren't already fluent with addition, subtraction within 1,000. But the traditional year-by-year adding a 0 to the progression of place value takes a pause to make sure that there's time to pay attention to the beginnings that are important in grade 3. And in addition to multiplication and division, I should also say fraction concepts are there as well. Let's look at 13, which shows a different sort of example in grade 7. Here, proportional relationships are high and probability is lower, and there are 2 bullet points to say about this. In grade 6 and 7, many people noticed that there's not a high-level organizer that says functions all the way through the K-12, and yet functional thinking is bubbling in the early grades, and proportional relationships are a pivot from multiplicative reasoning to functional thinking, and the clue to that is this word relationships, and it sets the stage for grade 8 when we finally have actually a high-level organizer called functions. And so there needs to be sufficient attention to that, and this is where the grain size issue comes in, because there's actually almost twice as many words used to talk about probability in grade 7 as there are about proportional relationships in grade 7. But there is, if anything, at least an inverse relationship in the priority to those things. You can see some of the results of this so far. We have a kind of a natural experiment if you move to slide 14. For those of you looking on the computer, it's probably clearer in color. This is a screenshot from the Surveys of Enacted Curriculum, which you can query this database yourself online. It's S as in Sam, E as in Echo, C as in Charlie, online, all one word. And this is how someone coded the Common Core standards in grade 7. And looking at, that there's a lot of words, there are 2 things. So one, probability is here coded as having equal time with basic algebra, which is the wrong focus for grade 7. And there's nothing coded for functions, which would send people away from all functional thinking, which is the wrong coherence and the wrong progression from multiplication division through to linear functions. So this shows the kind of things that can go haywire when you chop up the document into bits and feed the bits into some machine like punch cards. And it gets to the need to look at the standards holistically and think about the content holistically, which is a big challenge to do at scale. And I see a lot of the SBAC content spec and its emphasis on rich tasks as striving toward that kind of view of the standards. Now, I'm going to speed up because I know you have a lot to do, and just show, you have these slides, you can look at them. Let us skip to slide 16, a study that has just come out by David Conley and collaborators. And it surveys over 1,800 post-secondary instructors, and it's very exciting to see now people are beginning to study actually the standards themselves. The scatter plot that I showed you some while back was not about the Common Core standards, it was about topics. But these are now looking directly at the Common Core standards, and these instructors rated each of the standards in math, and in ELA, by the way, as how applicable they are to college-level work, and how important they are, and what sort of prerequisites, whether they're prerequisites, whether they're at the college level, and so on. And there was a range of courses and institutions, including, as you can see here, I think, business management, healthcare, computer technology, in addition to math, science, and in fact, English language arts, too. And if you look on number 17, there's a wealth of data in the study. There's really an awful lot, and I hope there will be disaggregations of it available, but even the raw data by standard, if you combine the percentage of faculty who said a standard was applicable to what they taught with the percent who said that it was a prerequisite for what they taught, and of those who did think it was applicable, how important they thought it was, if you just mush those into a heuristic sort index and sort, you see actually it's just common sense, but it is pretty striking how the different content clusters sort out in terms of a heuristic sort of priority. We have algebra coming in extremely important. Each bar is a cluster here. Number and quantity. This is quantitative reasoning. Quantitative literacy is prized by the instructors across the college curriculum. And now, if we look at number 18, it's the same bar chart in a kind of I forget what they call it. It's a scree plot, is it, where you sort them in descending? And you can see that there's just quite a long tail. And when you look at this data, and really also in the bibliography to the standards themselves, it comes out in really sort of needing 3 bins to capture the dynamic range that we see in the data. And so in the spec, there are really 3 bins of a first, a second, and a third priority. And in 19, for high school, it shows first, second, and then third is by comparison to the others, because there are so many clusters in high school. To put it on one page, it's there. And I'll just say one word about this and then open it up for questions. But in algebra, there's a lot there in the first priority, and you can see that it's really the meat of not only pure math, but also using the pure math, creating equations to describe numbers or relationships, and also solving them graphically, and writing expressions, translating a problem situation into an algebraic model. All these things are very rich activities, and in fact, they also cut across quite a range of technical sophistication. So there are going to be further decisions to make about, just what sorts of equations are in these boxes. So setting priorities has these advantages and answers some questions. It doesn't answer all the questions that will have to be answered at the detailed level of assessment design. So with that, I can open it up. Thank you for your attention. I know I talked for a long time.
Thank you, Jason. We actually have plenty of time. You ended even a little early, so I want to open it up for questions. There was a lot that was covered here, and this is really of course, the base for the content specifications itself, as these are the standards. So Let's open it up for questions.
Hi, Jason. This is Stanley Rabinowitz. How are you today?
Hi, good. Thank you. Nice hearing from you.
Yeah, I'm curious. So, what's your interpretation of a lower priority standard? Is it not important? Is it important just for a smaller segment of the population? How do you interpret? What does priority really mean here?
Right. There are a lot of aspects to this question. So in some, and I think it varies depending on what sort of piece of content we're talking about. For example, if you look at geometry has a lot of very low priority numbers, and there are a few reasons for that. One reason for that is that the faculty in the survey, they said what they said, right? And I'm trying to interpret, or like you say, channel what they say. And one reason a lot of the geometry is low is that the post-secondary faculty answered the questions put to them. It's not prerequisite to what they do. It's not done in what they do. And when it is, it's not very important. So it sorts low. However, there will be in some of those cases, like let's just say trigonometry of general triangles. Just pick an easy example. That is something that a student who wants to do a STEM career or take an AP physics course while in high school, they're going to have to know that. But we're talking about, at least in terms of college faculty, something like 8% of college faculty. So in some cases, it is about some students versus other students. As you know, college ready in the Common Core means is a threshold, right? It's ready to succeed in entry-level credit-bearing math courses in college without remediation. That is not meant to be a ceiling. It's meant to be more of a mile marker that you go past with some velocity. That will be the explanation for some of the low priorities. Now, in other cases, it's going to be that you need deeper mastery, that we need probably to set higher expectations than we have. For the stuff that's in the first priority, it really means being able to use it, being able to be procedurally fluent in it, being able to call on it in a modeling situation or scenario. So it's to some extent how high our expectations are or ought to be. There are cases too where some things are clearly important, but virtually nobody would say that they're prerequisite to college level work. So it's sometimes a question of what has to be done well when. And in early grades particularly, the structure of mathematics plays a role. There are things that are intricate and difficult and which are prerequisites for other intricate and difficult things, so that you get a kind of an exponential fall off in staying on track to college readiness if you don't pay more attention and more time to those things. Now, in terms of test construction, that's partly, that's not my specialty. I would think content in the third priority would be pretty aggressively sampled. Anything is fair game, obviously. It has to be fair game, it's in the standards, but whether it's virtually guaranteed always to be on, I would say that's up for grabs.
Hey, Jason, this is Joe.
Hi, Joe.
Hi. So we have included the prioritization as an appendix in the content specifications, because so much of the specification of the content of what's going to be on the assessment is informed by this prioritization of the standards.
Mm-hmm.
And what I've included is the prioritization as of the document that I got from you on that was dated May 31st. And I don't, looking at slide 19, I don't think the prioritization quite aligns with the clusters that we have in the May 31st version. So is this a moving kind of a settling down, a dust settling kind of a situation with regard to the prioritization? Or maybe I've misinterpreted the document.
It absolutely is, and I would say two things about it. One is that the documents SBAC produces will be consensus documents, and that you guys will take hold of these things and discuss them, and the states will, make such changes as seem important to them, and that's part of the process. But secondly, the slide 19 particularly emerged from a close study of Conley's results, which are new and strike me as important.
Okay.
And those are not available on May 31st. In fact, those
exactly. And in the appendix with regard to high school, we do make reference to David's study and do indicate that it hasn't yet been folded into this analysis.
Got it. And as I say, the slide 19 there is you can't. There's no source of evidence, even no aggregation of evidence that would allow you to just throw everything into a meat grinder and then spit out sensible priorities. So there is some thinking about curriculum and assessment and rich tasks and other things, and what would be a good kind of spanning set and what would be a good robust picture for an assessment that is consistent with what we see in the data.
And so I would want the work group co-chairs to take away from this conversation the notion that part of the important feedback that we need to receive with regard to this version of the content specifications in mathematics is a close look at those prioritizations and the way in which we've thought about them and characterized them. Because I agree with you, Jason, because there is no strong empirical base for this particular prioritization, it essentially is a consensus decision that learned participants need to come to.
But be careful, because I don't think, I think that if you look at slide, number 17.
Right.
There's a very strong signal here, and beware, because you're going to talk to experts who have been in the K-12 world and who are not used to basing these decisions based on evidence, and who are going to say, scratch their head and say, well, gosh, like, isn't geometry important? And I guess I'm not saying it's not. I'm just saying that your job is to measure college readiness, and that's an empirical question.
Yeah.
And partly what the standard is trying to do is bring us toward greater mastery of a core and greater focus and coherence. And if everything is up for grabs in a consensus process, then no culture can shift.
Mm-hmm. Point well taken. Thank you.
Jason, one more follow-up. This is Stanley again. So how much suppose we take the high school college readiness prioritization as meaningful? Does that mean we should generalize down to elementary or middle school? Might there not be different prioritization in the earlier grades based on, say, building blocks and other considerations?
I do believe the considerations evolve as you go from kindergarten up through the task of assessing college and career readiness. I absolutely do think that, and the prioritizations that Joe alluded to that I guess are in an appendix take those sorts of thinking and signals and desiderata into account.
Thank you, folks. Any other questions on or for Jason?
This is Oregon. We have a question. This is Kathleen Vanderwall, and I'm also on the item development work group. I certainly respect and relish from an academic point of view a leisurely discussion about the prioritization, but from a pragmatic point of view in terms of preparing items for the Smarter Balanced Common Assessment in just a few years, it seems quite a risk to move the prioritization target, and I'm very concerned that the document from 531 might be different from that you're speaking to today. So the prioritization that's reflected in the content specifications would be different from what you're presenting today. That's a concern, and just wanted you to address it. And also, in terms of the heuristic plots, is there a way to do those by grade or something so that we could see the prioritization from that point of view, say from grades 3 through 8 and high school?
You know, I wish there were, except that the commonly surveyed college instructors, and college instructors are not so interested in getting from A to B, they're interested in being at B. So this picture reflects back on earlier grades, but it doesn't, we don't have direct data about that. Actually the Common Core process as a whole mimicked this, because in 2009 there was a first cut at college and career readiness standards, and then a long process of back mapping, thinking about that. And so in a way this is similar, but it's not possible to create another graph. And like Stanley was saying, the considerations evolve as you work backwards in the grades, and they have a lot to do with the logical progressions that are built into the standards. And as I say, controlling issues like grain size in implementation that are not always controlled in the document. Now, what I will say is, I think you, like you say, there are pragmatic and operational reasons to settle on things, and I think this ought to be finalized very quickly. And but let's remember also the consortium, you know, a condition of funding and part of the proposal is that this assessment actually be useful for higher education. So there is going to be down the road a reckoning with the actual data and the actual validation of the data that this assessment produces. And so it is very much in your interest to get that as right as you can get it in the advance of that.
Just a follow-up question. And how is there an explicit plan for garnering this additional information from higher ed so that our work groups have that information at known points? For example, I hope that you're going to be very clear in the fine-tuning that you've done so that when our work group provides feedback on the content specifications in just a few weeks, that we're fully informed so that our input is actually valid. If we provide input based only on what SBAC has in all good faith developed based on 531 and it's actually out of date, I don't feel like wasting my time putting that all together unless it's accurate.
So let me just break in. Let me just break in and say,
explicit.
Sure. Let me just break in and say 3 through 8, there's no plans by myself, any other members of the writing team or working group that I know of. There's no one's, I think 3.8 is worth your attention now, and I actually think that what is on slide 19 in high school is also worth your attention now. We're not in a crisis of version control here, the way I'm afraid it sounded earlier in the call.
And
that's great.
I don't think that, this is Joe, I don't think that folks in work groups should be overly concerned with regard to this particular conversation. Between round 1 and round 2, we'll be engaged with both David and Jason to try to clarify the high school situation, and we'll be getting feedback from both of them. But there's plenty, believe me, there is plenty in the round 1 of the content specifications that is available for comment, that is really essentially, it's immaterial as to what, with regard to what what particular content we're talking about. It talks about the ways in which content can be blended, the kinds of problems we would put in front of youngsters. The claims are of critical importance about whether or not we have the claims right. You know, if one of the claims is problem solving, and that's an important claim, it seems to me that the particularities of the content that we're talking about problem solving in is not necessarily as important as whether or not we got the claim right, we're defining the claim correctly, and providing evidence for the claim, and so forth and so on. So I think we'll be in good shape, and it will be incorporated into the second round of review. Basically, David's study was available on Monday, and of last week, or maybe it was Tuesday even, and so we only just barely had an opportunity to learn enough about it to know that we needed to incorporate it, but not nearly enough time to incorporate it into this first round.
And just to follow up with the previous questioner, is there anything else that I can say about that along those lines? Because I'm trying to agree with you, and but also saying that I think we're in pretty good shape. I, for example, would be very interested to hear feedback on these now. They're ready, in my opinion.
Jason, this is Kevin in Utah. I've got a question for you related to the prioritization and the mathematical practices. Because clearly the prioritization is more, I don't know the right term for it, so I'm not going to try, but it's a sub-piece of the practices that really folds into the practices. So can you talk for us a little bit about what's the relationship, what should the relationship be between the prioritization of the content specified and the mathematical practices?
Yeah, and this is to some extent addressed. This is a very important question, and thank you for it, and to some extent addressed in the specification document, and I'll say a few words about it. One is all of the kind of wonky stuff that I've been showing you in the bar charts and scatter plots and the international reports, and et cetera, a lot of it is in, as it were, on the content dimensions of this problem. And the good news, bad news is that there are a number of gigantic design problems involved in the consortium's work. And Joe was alluding to that with the claims, and as you'll see in the specification about task types and all kinds of big questions. But one that you're alluding to is how the content and the practices work together. And the way I've come to think about this, so in the standards itself, it says that people doing curriculum and assessment and instruction have to connect content and practices. And it keeps saying that almost like a mantra without telling you how to do it. And the most important place that content and practices become connected is in a problem, in a math problem. A problem might or might not give you opportunities to engage in the kinds of classroom conversations or the kinds of student work that are envisioned in the standards for mathematical practice. And a lot of the content specification that you're looking at is a way to try to make practical bringing together the content and practices. And part of making it practical is focusing and prioritizing, because we can't expect, nor do we need, frankly, all the students to be doing all the stuff in all the same way. We need to create a space where people can really go deep and make sense of what's there and do rich tasks with what's there and use appropriate tools strategically and all of the ways we want math instruction to look. So there is definitely a connection, and focus and coherence are meant to make the mathematical practices realistic, because I believe, frankly, we have a world of math instruction now where they're a bit of a fantasy. And so all this wonky stuff about the content is not meant to give the impression that math instruction is all about content, but that we have a content problem to solve if we're going to make math instruction what we want it to be.
Hi, this is Alan Schoenfeld. Just to follow up on what Jason was saying, I'll note that I'll address that particular question directly when we get to the section on claims. It really is important both to give students an opportunity to develop proficiency at the mathematical practices, and in the context of doing so, you probably want to spend more time on high priority content than low priority content. And there will be an example of that when we get to the section on claims.
Thank you, Alan. And that also serves as a reminder of where we're at with the overall webinar. And with that, I would like to turn over to the next section, which is the overview of the content specifications. And we can turn it over to Linda Darling-Hammond.
Okay. Thanks so much, Jason. That was really interesting and helpful. I'm just going to remind folks who may not have been on the last webinar how we're approaching the process of developing content specifications. If you go to the next slide, everyone will remember that we're starting from an evidence-based design framework, and that what we're thinking about, if you remember Joe Ryan's talk, if you were on the last webinar for the ELA content specifications, we think about what is the kind of cognition we're trying to evaluate, what is it that we think students should understand and be able to do, what kind of evidence or observation do we need to make to support a judgment or an interpretation that in fact students can understand and do the things that we hope the assessment is revealing. And we do that in a process that has a sort of disciplined approach to looking at the research base for making those judgments. The next slide just reminds us that in the current understanding of validity around tests, the validity is not an attribute of the test itself, but really the degree to which the empirical evidence and theory support those interpretations of the scores. Next slide. Just to take those 3 points, the models of cognition that we're trying to draw upon describe how students may acquire knowledge and develop competence in a particular area. Sometimes we have empirical evidence on those points. Other times we have to rely on a theoretical frame that is not as fully tested empirically, and sometimes on professional judgment, expert information from practitioners. The models of cognition reflect as much scientific evidence as we can muster of those learning processes, and Jason talked a little about the ways in which those sort of hypotheses and evidence are being used in the mathematics standards. And then we describe what we currently understand may be a typical learning progression towards competence. The next slide. So those aspects of cognition are the things that we will use to, the areas that we want students to know and be able to do that we think we can track over time will end up supporting claims, and then we need to figure out what our evidence is that in fact students know and can do those things. And we need to be able to be sure as we're creating observations, which we might think of as items or tasks, that those are really well linked to the cognitive model, that they really do prompt students to say or do or create something that provides evidence that is strong evidence to support inferences about their knowledge, their skills, and their cognitive processes. So this really is a frame by which we evaluate the types of items and tasks that are needed to draw that inference about the cognition. And the next slide reminds us that the interpretations then use that evidence to make those claims about what students understand and can do. And the claims try to frame a manageable number of learning goals. This is the theme that we keep returning to, around which we can organize instruction, guide the specification of appropriate evidence, and provide a basis for meaningful reporting. In a few moments, Alan Schoenfeld will talk about the claims in the mathematics content specifications in the same way that Karen Hess did a couple of weeks ago in ELA. Next slide. So our approach to content specifications has been with the intention of creating a bridge between the standards and assessment, and then ultimately allowing that bridge to extend to instruction, to organize the standards around those major constructs, those major areas of cognition that are critical to the field and that express what students should learn and be able to do. The next slide. We are trying to think about this in a framework in which we're thinking about curriculum, assessment, and instruction as interrelated and conceptualized together. Next slide. And what you'll see in the content specifications are first these claims about the ability students should develop and how we will know what students understand and can do. There'll be a discussion of what would be appropriate evidence to tell us whether in fact students do have those understandings and skills and provide a disciplined approach to creating assessments. And you will also see prototypes, exemplar items, and tasks along with rubrics that illustrate how the abilities should be assessed, as well as annotations of those prototypes that explain the key features of the items and tasks that are important to measure the constructs. Next slide. Questions? Or we can move on to Alan to describe those claims.
Yeah, if there are any quick questions here, we actually combined that overview with the claims component that Alan will address. But as we're handing over the controls to Alan, are there any questions for Linda on that overview she gave us? Okay, we may have more questions at the conclusion of Alan's section. We're handing it over to Alan, and Alan, I believe you have control.
Okay, well, thank you very much, Carlos, and thank you, Linda, for setting the stage. What I'm going to do over the next 20 minutes is start with the big picture with regard to what's in the Common Core Standards for math, what the expectation for students are, and therefore what's essential to assess. I'll do that briefly, and then I'll show how those ideas are addressed in 4 major claims for mathematics assessment that lie at the heart of the assessment. And I'll take questions at that point. That sets the stage for Karen Hess, because she'll discuss how the claims give rise to the summative assessment targets, which are much more precise things for actually constructing the assessments. So, let me start with a bird's eye view of the Common Core Standards, and the easiest way to do that is merely to show the first part of the table of contents, which indicates there are 2 key things to focus on, and those are the standards for mathematical practice. The doing of mathematics, the kinds of mathematical proficiencies, the kinds of mathematical acts we expect students to be able to engage in, and the standards for mathematical content. And the comments that Jason made earlier have to do with the fact that these are deeply intertwined. We want students to learn to use the content in powerful ways, and that's what the practices are about. So I'm just going to take you through them really fast, just list them essentially. Students need to make sense of problems and persevere in solving them. They need to reason abstractly and quantitatively, construct viable arguments, and critique the reasoning of others. So essentially be intelligent consumers of argumentation and intelligent producers of argumentation. Be able to use the mathematics to model. There are lots of tools, from calculators to fancy mathematical symbol systems, and kids ought to get good at using them in the right ways. They ought to do so with appropriate precision, knowing when rough answers are fine and when they need to be really precise. Math is about structure, so they need to look for it and make use of it. And the thing about mathematics is that there are common, powerful patterns of reasoning that give rise to patterns that you can exploit in mathematics, so they should look for those. Okay. As Jason said, the standards for practice and for content need to be deeply interwoven with a focus on what's important. So this is some language from the document, and I'm not going to read my way all the way through it. You'll have the slides afterwards. But the key thing is that, yes, kids learn mathematical content, but they should learn it in contexts where they become powerful users of that content so that they develop the habits of mind that are those mathematical practices. They get used to making sense of problems. They get used to reasoning abstractly and quantitatively. And they're powerful in their use of that mathematics to both pure and applied things. And that's what the second paragraph about points of intersection is about. The content is the stuff you use, and you need to have important content at your fingertips. How you use it is with the practices, and what that means is that you do so in the curriculum. You learn to build the skills there, and you do so in assessment. The assessments have to tap into kids' ability to do that. So there's the short version. Kids need to learn the core content and the core practices, and assessment should provide kids with the opportunity to demonstrate their proficiency with both. So that's the key top-level idea for any mathematics assessment that's consistent with the common core practices. Now, that gets translated for us into the following claims. If you have that as your top-level goal, then the SBAC assessments focus on 4 claims regarding student proficiency. The first is largely about content knowledge. Students can explain and apply mathematical concepts and carry out mathematical procedures with precision and fluency. The second is about problem solving, but it's not just that one standard. When we do the expansion of these, you'll see it includes a lot of the practices. Students can frame and solve a range of complex problems in pure and applied mathematics. The third is about argumentation. Mathematics is something to think with. Mathematics is something to make cases with. So you need to be clear yourself, and you need to be clear with others. And the claim is students can clearly and precisely construct viable arguments to support their own reasoning and to critique the reasoning of others. And then 4 is about mathematical modeling, not math just as pure math, but math also. It applies to the real world in a large variety of ways. So we expect kids to be able to analyze complex real-world scenarios and use mathematical tools, use mathematical models to interpret and solve problems. In what follows, what I'm going to do is elaborate on each of the claims somewhat, and then briefly give you 2 examples of sample assessment items that show the way you can get at both some of the skills and some of the mathematical practices. So let me start with conceptual understanding and procedural fluency, which is claim number 1. This is the claim that focuses largely on the content standards in the Common Core standards with the kind of prioritization that Jason was talking about. All standards may be equal, but some are more equal than others in terms of their critical importance. And the content consists of the things that are described in grades 3 through 5. It focuses on number and operations, algebraic thinking, measurement and data, and geometry. At 6 through high school, the main concepts are number, algebra, functions, geometry, statistics, and probability. There's a picture that basically represents the kind of content that will be assessed, and I think this kind of representation is comfortable, and we know how to work with that kind of thing. that identifies the main topic areas that the assessments will focus on. What I'm going to do for each of the 4 claims is first say briefly what the claim is and then talk about the essential properties of tasks that assess that claim. So this is the claim Conceptual Understanding and Procedural Fluency. And this, of all the claims, is the one that we know how to assess most comfortably and that is most familiar to people in assessment systems. Content knowledge can be assessed by a variety of short items that include multiple choice, selected response, short constructed responses that typically focus on one particular skill or concept. There are also a variety of other items, for example, matching items where we describe 5 scenarios, give you 5 graphs, and the kids match the graphs to the scenarios, things like that. So there are a wide range of ways to assess conceptual understanding and procedural fluency. They can be assessed directly by short items. They're also accessible, and you'll see that when we get to the sample larger item, in the context of larger items, because if you're asking kids to solve a complex, meaningful problem, they'll be deploying their content knowledge, and you can assess what they have of that content knowledge. So that was claim 1. Claim 2 is problem solving, and here I just lifted some text directly from the Common Core standards to say what mathematically proficient students do when they look at a problem. They start by explaining to themselves the meaning of a problem and looking for ways to think about it, looking for ways to enter into it. They analyze the things they're given, the things they're given and what they want, and the mechanisms of getting there. They make conjectures about where to go. So there's a hint of metacognition here. They plan a solution rather than simply jump into a solution attempt. And in the process of grappling with complex problems, they consider analogous problems, special cases, and use other problem-solving heuristics as they do so. So that's the gist of the claim from the Common Core standards verbatim. And the question is, what are the aspects of tasks that assess that claim? Well, if you want to gather evidence about those things, you need tasks that present non-routine problems where a substantial part of the challenge is in deciding what to do and what mathematical tools to use, and that involve chains of autonomous reasoning so that the kid actually gets, the successful students get to grapple for 5 to 10 minutes, shorter amounts of time for younger students, with a complex problem, thinking their way through it and then explaining their thinking in the context of using important representational and procedural skills to solve the problem. So that's claim 2. Claim 3 is about mathematical argumentation and the ability to construct logical and compelling arguments and the ability to recognize when someone else's arguments meet those criteria or are not. Clearly, what you expect of students depends as a function of how old and sophisticated they are. But the pathway to mathematical clarity and logical argumentation starts very early. I assume that a large number of you know, for example, the video of Deborah Ball's 3rd grade class where students are talking about sums of even and odd numbers. And a 3rd grader says something on the order of, well, I think every time you add 2 odd numbers, you get an even number. And that's because, like, well, the first odd number is a whole bunch of pairs with 1 left over, and the second odd number is a whole bunch of pairs with 1 left over. And when you put them together, you have all those pairs, and then the 1 left over and 1 left over make another pair, so the result is even. And the fascinating thing about that is it's spoken in kid language. It's clearly not formal, but a university mathematician would recognize that as a complete coherent proof. And moving through the grades, the students would learn the ways to express that in formal mathematical language as a complete proof. So that's claim 3, and the essential properties of tasks that look for kids' abilities to construct and communicate coherent chains of reasoning are that they present a situation in which either propositions are given or students are encouraged to make their own conjectures. They ask students to test the propositions or conjectures with specific examples, and then they ask the students to construct chains of reasoning that justify or refute the propositions. So as an example of that, in one of, there's an assessment sampler that will be an appendix to the report that SBAC produces. And one of the tasks there says, this is about chains of discounts in a store. For a store is going to start by, in the first week, giving a 25% discount. The next week, all of those prices will be given a 25% discount. Third week, another 25% discount, and so on. Mary thinks that at the end of 4 weeks, all the items will be for free. Show that she's not right, correct her reasoning, and then explain what the case actually is. So the idea, again, is kids can be asked to look at chains of reasoning that are appropriate for their grade level, critique them, and produce their own, and tasks will provide them with the opportunity to do that. And then claim 4 is about mathematical modeling. So again, a verbatim selection from the Common Core standards. Modeling is the process of choosing and using appropriate mathematics and statistics to analyze empirical situations, to understand them better, and to improve decision making. And the figure that's below that is a standard representation of the modeling cycle, where students are given a problem. They have to formulate a model knowing the mathematics that they know, do some computations within the model, interpret it, see if it makes sense. If it does make sense, fine, go out and report it. If it doesn't, realize their model wasn't true to form, true to the thing they were trying to model, and redo it. So that's mathematical modeling, and if you're looking for evidence that kids can do that, you want tasks that present non-routine problems from the real world, where the solution involves some or all phases of the modeling cycle, in which for some of them at least, the students need to spend a fair amount of time figuring out just what's going on and which mathematical tools should be used. And again, these two, at least some of the tasks are going to call for chains of extended reasoning. Okay, now to get to the nature of the tasks and the relationship between tasks, assessment tasks, and the standards and practices that they assess, sometimes there are simple relationships and sometimes there aren't. So for example, if I show you the task, if x and y are positive integers and 3x plus 2y equals 13, what could the value of y be? Write all possible answers. You can make a pretty direct mapping from that task to content standard EE 8.1 and claim number 1. But what I want to show you now is a constructed response task that covers a lot more territory in what I think is an interesting way. The task is called Hurdles Race, and here's the scenario. You're a race commentator. You've been given this graph, which is a graph showing the actual trajectories of racers A, B, and C when those three racers, A, B, and C, performed in a 400-meter hurdle race. And your job is that you're the race commentator, and it's your job to write a commentary about what happened. And it says you don't need to measure anything accurately. What I'd like to do for 1 minute or so is take you through the mathematics in that as a kid might see it. For example, the first thing that a kid sees is that the dashed line for racer C is far off to the right, and at first that might lead the student to go, oh, look, racer C won. He's clearly out ahead of the others. Except then you have to stop and think and realize, oh, wait a second. The x-axis is time. The fact that he's that far out means actually he took the longest, so he lost the race. And it's the one who's closest to the left who won. Okay, let me start again and figure out what happened. Well, now, geez, it looks like racer A got off to a really fast start. And then what happened? There's this section of the graph that's horizontal. There's a key piece of mathematics at that point. A horizontal graph means that the distance isn't changing. So if the distance isn't changing, something must have happened in the context of a hurdles race. It's got to be he tripped on a hurdle, and it took him a while to get up. And after he got up, he was behind. So then you look at the other two racers, and you go, well, they were behind A until the race. And knowing that to the left is ahead means that racer A was ahead almost all the time, but at the very end, racer B kicked and got ahead. Now you have enough information that you can use to write a race commentary. Well, if you think about what's involved in terms of the context, you've got to interpret distance time graphs in a real-world context, and you heard the way that I was using the context to make sense of what was happening. You need to understand to the left is faster. I didn't say, and it should be part of a commentary, that at the point where B's graph crosses C's, that's where they're actually tied. And C then went ahead. You need to interpret everything and then write it together coherently. That's the content. There are loads of practices involved too, and I've bold-faced the ones that are most central for this particular task. You're going to spend some time sorting this out. You're not just following formulas, you're reasoning abstractly and qualitatively as you're going through this. You're making a story and you're doing mathematical modeling. And in this case, there is an issue of precision. Namely, it doesn't have to be that precise. You don't want to be writing a commentary that says, racer A is moving at 12 meters per second for the first so many seconds, et cetera, so that you're actively showing your mastery of the practices as you're writing the commentary. Some of these more heavily emphasized than others. And what you can imagine in a full-fledged assessment then is a set of items that includes a broad range of sampling using short items, a collection of items of this type that allow you to both dip deeply into the practices and allow the students to provide evidence that they're actually proficient at the practices, at the same time that both the larger tasks and the short items provide an adequate sampling of the space of content that's essential to assess. So that's the top level view. What's going to come next is Karen will talk about how to turn those into specific summative assessment targets, but we'll stop here and take questions. And I will pass control back to Carlos.
Thank you, Alan. And as Alan mentioned, it's time for questions. Are there questions for Alan's piece and or Linda's piece as well?
Alan, this is Tim Kurtz in New Hampshire. Do you have recommendations, in our system with the adaptive testing, we have a lot of items probably in the adaptive test that have to be able to be scored quickly and with kind of a right or wrong notion, and yet your presentation gave somewhat of a feeling that there's going to be maybe or should be a heavier emphasis on student thinking and explaining what they're doing, et cetera. Given what you know about our system, what would you make for recommendations on numbers of items and amount of time we should expect kids to be engaged in assessment?
That's a really interesting and important question. Here I want to say that, I'll speak as an individual, but the consortium itself is working on that whole issue, and Linda and Joe both and others shouldn't hesitate to jump in. I think there are two things. One is that the Common Core standards are very clear that the practices are absolutely central and that one does need to have items that assess them. How much of them? Well, the name of the consortium is the Smarter Balanced Assessment Consortium, and the idea is really a balance in terms of providing opportunities for students to demonstrate such capacities while as much as possible using testing technologies that make it as easy as possible to grade the exams. There are two things here. First, Linda and Joe tell me that there are emerging technologies that make it entirely feasible for ELA to assess kids' actual essays and things like that, and that there will soon be technologies for assessing much larger chunks of students' performance items in mathematics constructed responses. So I think we'll find the technology will enable us to do more than simply yes or no or multiple choice or things like that. The second thing is what I see as a double value for constructed response items. I think if you have one afternoon of testing, one chunk of testing that's 2 or 3 hours, and you have a collection of 3 or 4 items of this type, that gives you a huge amount of evidence about the practices and turns out not to be that expensive to have graded. And there are systems for moderating grades. The Europeans do this all the time. That mean that you can have teacher grading with other people doing sampling of the grading to make sure that the grading is fair. It doesn't take a huge amount of time with two benefits, I think. One is that a number of places have used such grading and training students on such samples as a form of professional development for both teachers and students. So I could point to particular examples where once people knew that there were assessment items like this, they used them as instructional items through the year and then work with the teachers to understand what their students were understanding as a form of formative assessment, which helped build capacity for the students. So if you look at the benefits to professional development and in some sense the alignment of classroom practice to the kinds of performance you'd like to see, those are pretty significant benefits which may outweigh the slight costs in teacher grading time, especially if the teachers are spending classroom time focusing on whether it's curriculum or assessment items used for curriculum, focusing on tasks that really have the students build proficiency with the practices. I'll stop there, and I wonder if either Linda or Joe would like to jump in at this point with regard to that.
This is Linda. I will I'll just add a thought or two, and Joe may also want to add something. I think Alan already expressed the fact that, there's a distance we can go in the scoring of constructed response items with computer-based scoring, and we're continually increasing our understanding of how far down that path we'll be able to go. As you know, and you'll see this when you see these sample items and tasks, the item development group also has developed some approaches to technology-enhanced items that make that kind of create a process by which that kind of scoring becomes more plausible. And I hope we'll be able to share soon something that Alan's team did, which is a little paper or appendix on technology based items that actually use gaming technologies as well as a way to evaluate students' higher order thinking and reasoning skills in ways that will be scoreable easily. The other conversation that we've begun to have with some of the work groups, but it's not, it's in process of moving towards a broader conversation that could result in some decisions, is that, as you know, we had said initially in the design for Smarter Bounce that both math and English language arts would have 2 performance tasks outside of the CAT engine. And one possibility is that that one of those performance tasks in math might be replaced by the use of some of these more extended items, a cluster of those items, as Alan described it, that would be at the edge where they need to be scored by teachers and would replace what would have been teacher scoring of one of the very ambitious performance, the more ambitious performance tasks.
Joe here. Good question, Tim. One we've been wrestling with this document, as well as we've been bringing it forward to make available for review, and not simply and solely this particular question, but actually the the world in which this question lives was part of the reason for our having to postpone release for a week, as we kind of tried to figure out, how explicit or unexplicit we are going to be in this document with regard to addressing that issue. I think it's important to keep in mind the purpose of the content specifications document, which is really to lay out the particular claims we think are important to make about students on a summative assessment of this sort, and to make those claims with some sense of reality that we actually could assess those things, but not to get so much into the definition of how they're going to be assessed that it stops being a content specifications and starts being a set of test specifications. So I think what we need to do with this first round of the content specs is ask for quality feedback on the claims, on the sense of what we think we're going to want to be saying about kids, and a little bit about how we might be doing it, but kind of hold off on the particularities of how we're going to do it until we start trying to solve that problem. And just know that we'll kind of do our damnedest to make sure that everything we want to do, we actually can do. It's part of why we asked Mark and Kathleen to provide that webinar for us. Was they are doing very exciting work and very innovative work in getting into students' deep thinking skills with items that actually can be machine scored. And so I think we all have a lot to learn about what's possible. But I think for now it's important for us to put sort of a stake in the ground with regard to what we think is important to say about students' mathematical proficiency.
This is Stanley. I want to follow up a little bit on Joe's response. We have the term balance in our title, and it's not just the assessment system we have to balance. We have to balance certain realities of what we can do today, what we be able to do, say, 10 years from now. If I'm thinking about that hurdle task, I can envision a combination of some multiple choice and some short constructed response that may not be an ideal way of measuring students' knowledge and abilities, but could get at most of what the intent is, and still provide, say, some scaffolding for lower performing students. So I think if we think about a mix of item types, even within these more ambitious tasks, we might have a realistic but still move the dial in the right direction.
I mean, yeah, for example, I can imagine an item where on the computer screen, students are asked to draw a fourth racer that has certain characteristics to them, and draw the line that would address those characteristics. That would, it seems to me, go a long way towards getting some insight into the extent to which the student understands, distance and time graphs. So anyway.
With that, that's actually, go ahead, Linda, please.
I was just going to, one last footnote, which is that to the extent that we're looking for responses that are short or long explanations, telling the story of what happened in the hurdles race, for example, what was going on here and who actually won and how do you explain the shape of the lines. That kind of text is, that sort of essay, if you will, is now readily scored with high reliabilities by computer on the NAEP and other places. What's going to be another challenging question to figure out is when students do their work in mathematics and we want to see work, we want to see what students show in their work, most kinds of problems we work by hand. And so that's actually more, in some ways, the challenge to figure out before every kid has an iPad in the shorter run, then how do we score explanations which fall more into the category of responses that have been readily scored by, more readily scored by computer in other contexts.
Linda, I'm really glad you brought that up. I was just about ready to interject the exact same point, that mathematics presents a unique challenge when you want to figure out how students solve problems. It really is a challenge. Yeah.
Okay, with that, thank you, folks. With that, let's move to the assessment targets. It's a fairly good segue given the recent conversation. So, Karen, are you ready? Just let us know and we'll proceed with the slides for you.
Okay, can you hear me?
I can hear you. Thank you.
Okay, good. Okay, you can go to the first slide. So my task was to be thinking about Jason's prioritization and how the standards are written and the number of standards, and also the piece that Alan worked on with others from the Shell Center to articulate the claims. And so the assessment targets, as with the ELA, indicate the prioritized clusters were taken into consideration, making links to specific standards and the kinds of items that would be developed. So as you already heard, Claim 1 items will be shorter items, probably selected response and short constructed response items. I would expect that mostly those would be CAT items, the computer items. And also, Claim 1, when you get the document, you'll notice that there are more assessment targets for Claim 1 because it's a broader sampling across most or all of the clusters, most of the clusters in high school. It would be impossible, I think, to assess all clusters, but some sampling of clusters in grades 3 through 8 probably can happen within Claim 1. Claims 2, 3, and 4, there are fewer assessment targets, and We anticipate that those would be more like the tasks that Alan was talking about with the hurdles task, probably constructed response or perhaps an extended performance task, which would incorporate a lot of the skills and concepts in deeper understanding. Go to the next slide. So the assessment targets would show how one or more standards could be bundled together because there's a similarity in the kind of content and probably in the kind of comparable rigor or depth of knowledge demand, just as we did with the ELA targets. Next slide. So here would be an example of a 4th grade target for Claim 1, which addresses conceptual understanding and procedural fluency on the left column of the table. You'll see some keywords using operations. Then you'll see a description where students are using whole numbers and the 4 operations. They're going to find the unknown when given an equation, which might include letters. And they're going to solve multi-step problems using operations. And then it gives a little bit of the parameters, including problems requiring interpretations of remainders. Then you'll see the standards that will be tapped for those items. And in this case, it would be operations and algebraic thinking standards 2 and 3. And then there are depth of knowledge levels listed below that. In the middle column, you'll see what's underlined is the part of those standards that probably will be tapped with these shorter items. So you notice it's not the entire standard, but they're going to multiply or divide to solve a problem. And in standard 3, they're going to solve problems, but everything isn't underlined. So if you look at the far right column, the types of items that this would probably be related to are multiplying and dividing to solve a word problem, not a problem-solving task, but a simple word problem. They might involve multiplicative comparisons, would involve whole numbers, having whole number answers using the 4 operations, as well as having remainders. And then there's a note that says this last part of Standard 3 would probably be addressed under Claim 3, which is the reasoning claim. So if there was a task where students are asked to assess the reasonableness of an answer using estimation strategies and rounding and so on, there you might see that same standard listed with a target under Claim 3, but you may not see it under Claim 1. And so in this way, you'll see some of the same standards, but the descriptions in the target will be slightly different. Go to the next slide. The depth of knowledge levels. On this slide, I just have some examples of descriptions of if you see a DOK1 or a DOK2, and there is an Appendix B, which will come with the document that has probably richer descriptions than these, but just to try to pull out a few. So I would anticipate Claim 1 hitting DOK1 and DOK2, the kinds of things that are listed there, evaluating an expression, representing math relationships, extending patterns, translating between tables and graphs. Claims 2, 3, and 4, you will see indications that most of those are going to be at a depth of knowledge 2 or 3. When they have non-routine problems or they're drawing conclusions or citing evidence, you'll see the richer task will be able to do that. Next slide. So this is what an assessment target might look like, and this isn't all of Claim 2, but it's most of it. So Claim 1 for 4th grade actually has 13 assessment targets, but Claim 2 would have more like 4 or 5, and that's consistent across the grades. And so it will start with stating the claim. Students can frame and solve a range of complex problems in pure and applied mathematics. Then you'll see some conditions, and this is where there's an indication that the content prioritization was used to decide what would fall under each claim. So for example, if it's on the first tier of prioritization, you're going to see it under Claim 1. You're probably going to see that content under Claim 2, maybe 3, and 4. So you'll see it more often for the highest tiered prioritization where that third tier that Jason was talking about, you'll see more of a sampling, and maybe you'll see it show up under one other claim. And that was a way we were trying to think about how to address the prioritization and give some balance. So here then you see what the targets look like. So for problem-solving targets, students, all of these at 4th grade start with given a scenario or a context. So they're going to be given some kind of a context, maybe like the hurdles race. They have to come up with a strategy. It's probably going to be a multi-step problem. But you'll notice that in target 1, they're going to be using whole numbers, and they're probably going to be generating an equation, a diagram, or representations to support their solution. In target 2, they're doing a problem-solving task with fractions and mixed numbers, and possibly decimal notation. And number 3 taps things like distance, time, liquid, measurement, and data. So the standards are changing. And to go back to Tim's question, I don't know that you would see a task for each of these from Claim 2 in a given year, but you might see a problem-solving task with whole numbers, and then you might see in Claim 3 a reasoning problem with fractions, and you might see a real-world application of modeling for data. So that's kind of going back to Stanley's comment about the balance. The idea is, first you might want to think about what are the tasks that would make up Claims 2, 3, and 4, and then what kind of sampling do you need from Claim 1 to balance it out. So you have a full look at the curriculum, but you're giving more emphasis to the places where there's deeper understanding expected. Next slide. Oh, I'm done. That was fast. Questions?
Karen, this is Kevin, Utah. I saw slide 53, which was sort of a very detailed look at a single target. And then I saw the very last slide we were at, and I couldn't see the slide number, which sort of lists all the targets. What's the relationship between what we saw on slide 53 and what we saw on that last slide that you showed? I want to believe that there's a slide 53 for every target, but I just want to confirm that.
Right now there isn't that detailed breakdown. I think that's what the task is for the test design group, is to really break apart the targets and determine what exactly those items will look like. What the document will look like is more like what you see on slide 55, which is it will list 3 or 4 or 13 targets. It will give you the standards, and then what I would envision the next step to be is to take each of those targets and say, well, how would we frame the types of items if we tap these particular standards? I would also not expect, even though there might be 3 or 4 ideas embedded in assessment target, that you might assess all of those on a given year, but you might, on one year, assess a particular aspect of it, so that in sort of in a rotating basis, you've hit all of the targets, but maybe you haven't hit every aspect of the target. The first question about how many items, I would think if you have for Claim 1 12 or 13 targets, you might have a couple of items for each target on a given year in the CAT part of the test. That's where the test blueprint is going to decide, does each target get 2 items, or do some targets get 1 item and other targets get 3, because there's more involved with the description of that. But I think what you're asking for is probably what the next step is for probably a work group to take each grade level and think about the test blueprint using the targets.
Yeah, I think that's right, Karen. And also, you know, some of the tasks that are used for claims 2, 3, and 4 will have components of them, parts of them, that actually address claim 1. So they will kind of, in some instances, part of what's going on in a modeling, you know, in a modeling task could well be assessing your how well you can traverse through the necessary content knowledge and procedural knowledge to solve that problem. So there'll likely be some short response items embedded inside the claims 2, 3, and 4 tasks that map back to these map back to claim 1. So it's not like there's a claim 1 part of the test that's a complete standalone from the claims 2, 3, and 4 part of the test. They'll have to be integrated to some extent.
Right. As a matter of fact, I would just add that if a particular claim 1 included addition, subtraction, and multiplication of fractions, you might not see all of those in the CAT portion, but you might see addition of fractions in one task and multiplication of fractions in another, embedded in maybe a modeling or a problem-solving task. So right. I think that, and I think you can probably, with the headers of the clusters or the domains, excuse me, that they come from, that would be a way a test design group could look across it and say, what could the blueprint say about how these targets are applied? Are there other questions for this section before we move on to the feedback process? Okay, with that, we'll move on, and Joe, I'll hand it over to you.
Okay, thanks. So one slide we inserted here that's not necessarily part of the feedback process, but is sort of the tail end of the claims and the targets, is the score reporting categories. This is a section in the document that you'll be receiving. It's not as fully detailed as it was in ELA. You may recall that after each claim in ELA, we provided some information about score reporting categories. Actually, there's a single summary table with a little bit of text that supports it in front of the targets in the document you'll get that talks about the score reporting categories. The notion is that in addition to the total score for mathematics, which is in the green bar across the top, which kind of is the bundling of everything together, there would be then 4 subscores. There'd be a concepts and procedures subscore. I'm reading down the columns now. The second is the problem-solving score, a communicating reasoning score, and a modeling and data analysis score. So it'd be those 4 scores. There's probably not enough points in the assessment within problem-solving or within communicating or within modeling to break them down in much more detail than simply a score for that category. But we'd be desirous, since we're making claims in each of those 4 areas, that we do have a score for problem solving, a score for communicating, and a score for modeling and data analysis. When it comes to concepts and procedures, which is claim number 1, it's likely, given that there will some of this will be assessed as standalone items, and some will be assessed inside scenarios. There'll probably be enough points to get to the priority areas in those grade levels. And as you know from Jason's discussion, the priority areas shift from grade to grade to grade. So what's given here are what we are kind of throwing out or proposing as score reporting categories at each grade level within concepts and procedures. So in addition to an overall concepts and procedure score, for example, at grade 3, there'd be a subscore for operations and algebraic thinking, a subscore for number and operations for using fractions, and a subscore for measurement and data. and then so on down the line. I won't read them all to you. You can have them there, and they're in the report. But that's the notion at this point with regard to what we think we can do in reporting categories. This would generate something on the order of either 6 or 7 sub-scores per assessment. And given Linda's notion that we've been throwing around of taking one of those performance tasks and having it be using some of these shorter item or the shorter tasks and scenarios, we probably will get enough observations that we could support that many scores. But it is a lot of scores to support. I want to acknowledge that and am interested in feedback on this particular concept.
Can I say a word about that? This is Jason.
Yeah, sure.
Thanks. I would just caution that I think domain subscores is going to, I think it's good. I think it's going to have to prove to be a kind of a flexible thing. Like in 3rd grade, the actual span of what's going on in base 10 in the NBT domain is as I say, quite small. It's a fluency standard, and you don't want to rope yourself into a situation where you have to, devote 10 items to something that is actually meant to be on the back burner. And to artificially to get over some perceived or real reliability hurdle. I would also say the same of geometry in 3rd grade, which is sort of even smaller. And so, I think it would be nice to have those domain scores where it's natural to do it. Otherwise, like I say, the requirements of reliability can end up distorting things back. Right.
Agreed. And that's why we're very interested in feedback on this and interested in, your thinking and Sandra's thinking and so forth and so on with regard to this.
Great. Okay, thanks. That was all I just wanted to add.
In the interest of time, we only have a few more minutes, so let me slide through the next slide, which is the one more. There we go. It's where we are on the calendar. So today is the 29th. We're having our webinar. We'll be releasing the round 1 later this afternoon. Then also today at midnight is the feedback is due for ELA round 1. And so if you haven't turned in your papers yet, they're still due. And then on the 19th will be the feedback due from this round of mathematics. Also on the 19th, we will release the round 2 ELA literacy for a 1-week feedback loop, and that comes back to us on the 26th. And then the final content specifications, I don't think that's right. I don't know what that row is doing in there. Row number 8 you can ignore. Row number 9 is releasing round 2 for mathematics, which is due a week later on the 17th, and then our final will come out on the 24th. That's what our calendar looks like. Christian, please confirm that row number 8 either has meaning that I don't see or is not part of the final report. I don't know which it is.
Again, that's row number 8 is specifically regarding the ELA literacy, so that's tracking there. But we can talk offline.
Okay. I was thinking that row number 11 would be the combined for everything, but okay, I understand. Thank you very much. Okay.
Welcome.
Thanks. Good. Next slide is a survey walkthrough, and do we have time for a survey walkthrough or no?
We have 5 minutes. We can go through, like we did last time, just some of the key questions to point out the facets of the survey, the demographic, quickly, and
there may be people online, math people who weren't part of the ELA release. So I'll hand it off to you.
Okay. So we wanted to just go through again the key facets. So we've got you'll start the survey. This is the group survey. To start off, there is a group survey that you can participate in, and then there's an individual survey. We're showing you the group survey. Of course, the first question is just to check in to make sure that you're actually a group, and we want to make sure that if you aren't, then it sends you a message saying you should be taking the individual survey. So you start and proceed through with this, and then go into some demographic kind of questions. who you are, who you represent, and then the first meaty question is really about the overall impression of the content specifications itself. And you can see if we scroll a little bit, you can see that these questions are of a Likert scale type, asking, posing a statement and asking whether or not your degree of agreement with that. Again, this one is an overall, and for most of these questions, you will see there is the text space so that you can actually provide a narrative commentary as well. And I believe we've shifted over to the claim-specific questions here. So there's that overall I just mentioned. Then you'll move into questions for each of the claims. So it's a series of questions that basically repeat themselves for each of the claims. And Joe, do you want to, anything you'd like to interject so far? Okay, I'll just keep going.
No, just we invite and encourage folks in the States to convene as many people as you can, and also let everybody else out in the community, in your districts and in your regional centers and in your various, groups within your state, your associations and your administrator groups and so forth and so on, know about this opportunity. At the very end, we do have an area that lets us, where we ask who you are, and we also ask you if you're interested in finding out more about the consortium, and if so, you'll get on our weekly update list and so forth and so on.
And again, this is optional. However, we really want to encourage you to indicate your information if possible. It helps us track to make sure we're getting responses from folks. And with that, we have not much time. Are there any questions from folks listening in who haven't been able to ask some questions? We have about 2 minutes left. Hearing no questions, any closing remarks?
So Christian, when do we think we'll be able to hit the send button on this? Do you have any idea?
Yeah, I do have an idea. I would say it will absolutely be today, and I would say it'll be probably around 3 o'clock our time here.
Okay, great.
Okay.
Wonderful.
Yep. Okay, any closing remarks or questions for folks?
If Judy or Carissa are on the phone, I'd invite them to close out for us. I don't know if they're on or not. They're on mute. One never knows if one's on mute.
I'm on here, but I think you guys have done a nice job, and I don't have anything else to add. Thank you for setting this up.
Thanks, Carissa. Okay. I think we're good. Keep in touch.
Thanks to everyone.